Thank you for having me here. I want to say special thanks to the MobiConf team for organizing this event this year and all the past events. I've been a huge fan of this conference. I hope next year or the year after I'll be able to be with everyone in person. And also thank you to everyone that's on the other side of the screen for taking the time to come to my talk, and hope that everyone is safe. So before I start, please let me give a big round of applause to everyone. It's not awkward at all to clap on an empty room, but let's do it. So welcome to this an Android, a desktop, and a web developer enter in a bar. Of course, we're all following the public health measures, so don't worry, everything is okay. And who am I? My name is Carlos Mota. I'm from Portugal. You can find me on Twitter at @cafonsmota. I'm an Android GDE. I've been working with Android for the past 10 years. I've been playing on the last 3 with Kotlin Multiplatform, and this year I've been focused with Compose and Kotlin Multiplatform. I'm also the organizer of GDG Coimbra and Kotlin Nights. I've been writing at Hey Wonderlic, and I love travel, photography, and running. And I look forward to one day have the chance to taste the Ziwik Bial. I hope I've pronounced it right with all of you. And if you think this is not the best beer, I'm also looking forward for you to tell me which one it is and to try all the excellent beer you have. I've created a couple of materials for this talk, so you can find the slides at my speaker deck. I'm going to tweet all of these links at the end. I've also created 2 GitHub repositories. One is called Alicers, and you'll know at the end of this talk why. And the other is called Unsplash. This is because I've created an application in Android, desktop, and web. I think when you're expanding something, it's always good to have an example so you can dive in. And I have a newly created YouTube channel where I'm giving small workshops on how you can do a Kotlin Multiplatform and Compose project. I needed to use a Bitlink link because I only have 30 subscribers. So let me have my YouTube moment and say, if you want to watch my videos, you can always subscribe to my channel. So during this day, we've watched a couple of talks that I think that they are worth mentioning. For instance, one focused on Compose by Philippe Babbiek on how we built a Jetpack Compose chat SDK, and one focused on Kotlin Multiplatform by Enrique, KMP for mobile developers. If you hadn't had the chance, please watch them out because they're focused on part of what I'm speaking today. A brief history of time. So since 2006, a lot of companies tried to sell us that they're going to save us time and money with this amazing framework that you're going to build it once and run it everywhere and all platforms. And we keep seeing new solutions for this. We started with PhoneGap, Xamarin, RubyMotion, Ionic, React Native, and now we have Kotlin Multiplatform and Flutter. And if we go to another platform, for instance, if you go to desktop, it's a similar situation with less frameworks. And if we go to the web, well, I think there is some kind of joke where if someone is in coma and it wakes after 1 month, the world will evolve and 20 new JavaScript frameworks will be launched. And I think it's exactly this. There are a lot of frameworks that are used on JavaScript. I selected the one that appeared on the top 10. So sorry if this is not top 10. This is what was Google show me. Since we have a lot of frameworks and people with different opinions, a lot of myths appear from this. If we should use native, hybrid, or cross-platform solution, and usually there are a lot of arguments about this. So imagine this conversation. I've got a new app idea, and not sure why. I have a group with people with different opinions about tech. So one of them is going to say, oh, we're going to do it natively. And suddenly, as someone saw native, is going to answer, you can use Xamarin, and instead of Android only, you get Android and iOS. And then someone from Flutter side is going to say, for that, you should use Flutter. It has a better performance. And I'm on that chat, so I'm going to say, but it used Dart. You're already familiar with Kotlin. You should try Kotlin Multiplatform. And someone from the web is going to say, I've been using React Native and it's great. And then there are more 12 people with their opinions saying that their framework is the best. And in the end, you have no clue which one you should choose. So how to develop an application? There are a lot of factors that affect your decision, and I think all of these approaches are valid. So the first one is your team, the team that you're going to use to build your application. So if the team is already familiar with web, for instance, perhaps it makes sense to use a web approach. So if you have the chance to have developers focus on Android and iOS, perhaps across platform or even doing things natively. If you're developing a project that's just an MVP that you want to make a proof of concept and time is running out, perhaps doing something on web is more than enough. And of course, there are always constraints about time. Sometimes you're already behind schedule, so you can't learn a new framework. And there is budget. Can you hire more people? Can you allocate more people? So there are a lot of things that you need to think about. Of course, there are common disadvantages that all of these frameworks have. For instance, you are dependent on the framework. I've had an issue a couple of years ago where I've built an application using a specific framework, and there was a huge update on iOS. And I needed to wait a couple of months for the framework to make that same update. And then once the update was made, I needed to recompile my application, send it to the store. And at that moment, I lost 70% of the users that was using my app because it still looked old on a new OS version. So things take time to update. Sometimes there are missing features. For instance, if one platform doesn't support something, typically the framework won't support it. And you've got a slower performance because you're working on top on another layer, so things take time. And you're committing to one framework. And what I mentioned previously, if your project is going to take 1 year, so the framework will live 1 year, but what will happen in 5 years' time, in 10 years' time? Does the framework still exist, or are you going to refactor your whole application and perhaps do code on the framework because there is no support? There are a lot of things that you need to think about before selecting one of them. Of course, I've already selected one. A couple of spoilers here. From my point of view, one of the best out there, it's Kotlin Multiplatform. And I'm telling you why. So first, it's Kotlin. We'll all love Kotlin, of course. And you can take advantage of all the language features that if you're coming from Android, you're already familiar with. You have low risk, and this for me, it's one of its main advantages because you don't need to do everything with Kotlin Multiplatform. You can just start small. You are going to implement a new feature and you can do that feature on multi-platform. You want to add a database to your application, you can do that part on multi-platform. You don't have to do everything. You don't need to commit your entire project or refactor your entire project like the other frameworks need. You've got consistency across platforms. It's one tech stack. And someone might argue that, okay, if you have a bug, you have a bug on all platforms. And my answer is, okay, if you fix a bug on all platforms. And you've got a strong community support. The Kotlin Lang Slack is full of people enthusiastic about Kotlin Multiplatform. JetBrains is pushing Kotlin Multiplatform. You see Google trying to push Kotlin. So we've got the ecosystem already created. Talking about Kotlin Multiplatform. So Kotlin Multiplatform, the goal is to share your business logic. It's not to share the UI, just share the business logic. Network, parsers, all of these parts. Imagine that you want to create an Android application. You have the view, your activities, and then you're going to create a presentation layer, a model, a parser, the network layer. And then if you're targeting iOS, web, desktop, you're going to do the exact same things on all of these platforms. And truth to be said, it's this business logic part, it's going to be the same on all. On Android, for instance, you can use retrofit for accessing the network layer to access your servers. On iOS, you might use Alamo Fire. So, but basically they are the same thing on different platforms. So the goal of Kotlin Multiplatform is just to merge all of this and share this business logic. And then you can leave the views, the UI to be developed natively or even with a framework. You're not limited to do everything natively. You can just add a framework if you think it makes sense. I've been talking about multi-platform, But of course, there are times that you need to have specific behaviors depending on the platform at hand. For instance, on Android, if we want to access to preference, to settings, we use shared preferences. But on iOS, for instance, use NES user defaults. So there are different implementations to what you want to do. So this support needs to be given. As we saw on the talk before, if you want to define something that's going to be platform specific, you've got a folder inside your KMP project or KMM, Kotlin Multiplatform Mobile, and you use the keyword expect, and then you're going to say, okay, I expect someone that's going to define what name is. And in this case, we want name to be depending on the platform at hand. So if we're running on Android, we want name to be Android. So actually, what name means in Android, it's Android. And then since we're targeting desktop and web, we're going to do the same thing for the other platforms. As you can see on the right, I'm using different packages. So I'm on command main, where I have this command code and what I expect someone to define. And then I'm going to define on Android main, desktop main, and web main what it really means. So in the end, what happens is I'm going to generate a jar file, an R file, a framework I can publish to NPM. I'm going to have a library that I can use on my project with all of these functionalities. So how to develop an application with Kotlin Multiplatform, and we can go even further. And what we've seen this year is with Compose. So what is Compose? Once again, we had this amazing talk on the beginning, so I'm not going to go with much detail. But if we go to the Compose website, we're going to see a lot of buzzwords. So we're going to have less code, it's intuitive, it makes your development way faster, it's really powerful. And this is all true. I've been using Compose throughout this year, and I've been loving using it. I noticed that, okay, the first weeks and even months, it takes you a bit more time because you need to be familiar with this new UI toolkit. But after you learn how it works, it really speeds up your development. You can reuse a lot of code. We already have a lot of libraries that allow you to reuse code, to use code. And in the end, you can create things faster with less issues, which is what we all want. We've been talking about Compose, and then there was a tweet by Jack Wharton that made me think, because I never thought about this before, but it's true. Jake was building an internal project at Square for iOS that used Compose. And of course, a lot of people were asking, but there is Compose for iOS. What does this mean? And he was just making an internal POC, but truth to be told, there's more to Compose that we already know. For instance, there are this amount of Compose libraries. We've got Compose Animation, Material, Foundation, UI. And then we have the runtime and compiler. If we create an high-level diagram, you have the animation, material, foundation, and UI that are part of the Compose UI toolkit. And then we have the runtime and the compiler that can be used independently. So let's look at the compiler. The compiler is totally written in Kotlin. Basically, what it does is it transforms the composable functions into UI. It's really fast. It doesn't use the annotation processor. And this is a plugin that works at the code generation level. If you want to know more about the Compose compiler, of course, you can always dive in on the source code. It's on the OSP on this, there is a link. And it's the base to a lot of projects that come from Compose. For instance, Wharton also launched Mosaic. That's for the command line where you can use Compose. You've got runtime. That is platform agnostic, so it doesn't know what Android is or what UI is, and it's a tree management solution. It's responsible to map the functions into something that will be able to run. About the Compose UI toolkit, we've got the Compose UI that handles input management, entering text on text fields, etc. You've got the foundations that you have the column, the text, the image, all the components, all the functions that you can use to draw on the screen. You've got the material design systems that you can use, and animation, an amazing library with animations almost outside of the box that you can achieve with really a small number of lines. Being said, you can have the Compose runtime and the Compose compiler, and then you just need to add the Compose UI for all of these platforms. And with this in mind, JetBrains announced a couple of months ago there is Compose Multiplatform Alpha for desktop, web, and Android toolkit. And this is where we are at. So we want to develop for Android, desktop, and web. I decided to create a project that you can dive in, and for that I'm connecting to the Unsplash API. I don't need to worry about the server, I just connect and ask for the most trending images. And as you can see, these are the most trending image at the moment. I'm going to search a bit about Portugal and just load the 10 first requests. So this is Portugal. And then I'm navigating between two screens, a really simple application. Once I've done this Compose application for Android, I decided to share this code, and then I've implemented the desktop version. I know that this might seem that it is Android, but it's not. I'm running on desktop. As you can see, there are a bit different. I don't have the top bar on top because I already have the title name. And the great thing here is that there is a Windows API that allows me to resize. So I've got a desktop application here that I can just use as a normal application. And I'm reusing all the code. If you then go to the web, it's way more tricky to do. It's more difficult to share the code. So here I'm sharing the logic and small snippets just so you can see how it's possible also to share. And as you can see, I'm running it on the web. So I know the big question that you're all asking now is, now that we've got Android app, how quickly can we have desktop and web applications? You've all thought how True Manager is. So how can we also migrate everything to desktop and web? And so let's play a game. Okay, select your level. You just want to see the story. You want a lighter experience. Give me the full challenge, and let's go for the full challenge to explain how everything gets together. So we've got the Kotlin Multiplatform, where we share our business logic, and then we're going to have the Compose that shares our native UI. So let's start with Kotlin Multiplatform. So on Kotlin Multiplatform, we have a lot of targets that we can reach. You can have it on Android, iOS, JVM, GS, Windows, Linux. You can even have it on your watch. And all of these targets are possible to share your code with. There is also a large number of libraries that nowadays we can use. For instance, you can use Kotlin routine, serialization, the time, network, Ketor, SQLite for database. You can use Kotlin for dependency injection, multi-platform settings for settings, and there is a full list with all these libraries and more under this link. But this means that your application needs to be built with these libraries. You cannot have Java code at multi-platform level. You can only have Kotlin. So how to start? Imagine that we've got an Android application already designed, already developed, or you want to create one from the start. So the first thing that you should do is install the Kotlin Multiplatform Mobile KMM plugin on Android Studio, and then select Create a New Application. Once you've done, you're going to see that your project structure is a bit different than the one you're used to from Android. You're going to have Android app, you're going to have iOS app and shared. So we don't want iOS app, so we're going to have desktop app and web app, just copy paste and rename. And then on shared, you're going to have 3 different folders, each one depending on the platform that you're using. So in our case, we want to have desktop and GS main. On common main is where your common code is going to be, all the network requests, storing on the database, everything, and of course all your expects. And on common main, you're going to on Android main, desktop main, and GS main, you're going to have the actual meaning of the platform dependent code. So as you saw, I've switched from iOS to have desktop and web. So basically, if you go to your build.gradle.kts file from shared folder, you're going to have Android and iOS. This means that I'm targeting Android and iOS, but I want to target desktop and web. So basically what I need to do is just to call JVM with desktop and then define that I also want to go for the web. And in this case, on the web, I'm going to use the IR compiler. The IR compiler, it's JetBrains is being developing IR compiler, and you can have a lot of gains, especially when we talk about the generated GS file. Now that we've defined these targets, we also need to define the source sets. For instance, there is code that needs to be platform specific. For instance, on Android, I need to have a Ktor client engine. So in order to implement it, I need to load that library. On GS main, I need the client GS. In case of desktop, I don't need it because core is enough. So when you have an Android application already built, you need to migrate your existing code, for instance, from retrofit to Ktor. Retrofit use Java functions, Java classes, and once again, Kotlin Multiplatform needs to be full Kotlin. So the solution here is to use Ktor. For databases, you need to migrate to SQLite. For serialization, you need to use Kotlin X serialization. And of course, I'm just saying the imports that you need to do, but you need to migrate all the API calls. You're probably thinking that, okay, but refactoring my whole application is going to take a lot of time. So do I need to refactor the entire project? No. Okay. The great advantage for Kotlin Multiplatform is that you don't need to commit your entire code base to Kotlin Multiplatform. You can start small. Here are a couple of applications that are already on production that use KMP on their code base. For instance, Space from JetBrains is full Kotlin Multiplatform. Cache App shares the business logic. Index Maps shares the business logic and wrappers for C++ libraries. Plan Grid shares business logic, sync logic, and management of line data. And we keep seeing new posts of new production apps that are using multi-platform. For instance, if I'm not mistaken, a couple of months ago, Netflix just made a small update on their app where they share it on multi-platform. So the goal here is to start small. Perhaps you need to implement a new feature. So why not doing on multi-platform, on the shared model? Or perhaps you need to refactor part of your app because you're having a couple of issues there and you want to improve it. Well, it's a good time to do it on multi-platform. Or you want to improve your test coverage. You can create these tests on multi-platform. My advice here is when you moved from Java to Kotlin, you took a lot of measures to guarantee that you're not doing something wrong and jeopardize all your projects. So follow the same measures that we did back then, now to have your code on multi-platform. Of course, along the way, you're going to find a lot of challenges. Kotlin Multiplatform is still on its alpha state. Although, if I'm not mistaken, Kotlin launched today a roadmap for their live events, and supposedly it would go beta until the end of this month. But it's important to take into account that not all libraries are still available on Kotlin Multiplatform. Some of them that there are might not support all targets, for instance, JavaScript, the web, and they might not be compatible with your Kotlin version. I would say that the most common ones are, like Ktor, SQLite, etc. They are all compatible with the latest version of Kotlin, but there are some libraries that, they didn't get updated, so they won't work with your project. The initial setup requires some time, especially to have everything ready and working without any issue. For instance, you will have to do a lot of invalidate cache and restart every time that you add a new platform. There are properties that you're not familiar with, and there is not much documentation about them that you need to define. For instance, if you want the functions to be available on the iOS, you need to use export. On the web, if you're using the AR compiler, basically you have the function and an hash after that that responds to a bit of garbage of what it's being generated. So to avoid that, you need to use an annotation called GSName. And of course, on web, you should enable the IR compiler. It's also worth to mention that when targeting the web, your generated file, it's going to have several megabytes, okay? Ktor, serialization, these two libraries use a lot of size. Of course, there are solutions to try to overcome them. For instance, I've gzipped the GS file that's going to be fetched. And also I've minimized the file that's going to be compressed. So these two solutions allow me to go from, I think at the time I was 6 megabytes to just 1. Of course, you can then split your models, and with that we'll have less code, so your final GS files will be smaller. Talking about compose, how to start. So if you're going to compose for the first time, my advice is just do it first on Android, and then think about adapting it to desktop and web. And I'm saying this because developing in Compose, it's a totally different paradigm. You're going to develop your UI declaratively, and well, most of us weren't used to it when we used XMLs. So start developing it for Android, see if it works, and then move that code to desktop. If you're already familiar with Compose, you can always go dive in directly onto the desktop, and for that, just create a model called shared UI. You can just copy paste shared and just rename it to shared UI and remove all the Kotlin classes. To share your Compose UI code, you're going to need to know a bit about Kotlin Multiplatform. Thankfully, you've just watched an entire intro on Kotlin Multiplatform, so this is going to be easy for you. And I'm saying this because depending on the platform at hand, you're going to have different behaviors. For instance, on the desktop, you can resize the window without any problem. On Android, you can't, or well, I've added this asterisk here because I know that someone thought, okay, yes, you can always use split screen to have two applications on the same screen. Of course, you can, but it's not the same behavior, let's say. So you've got your project structure with Android, desktop, web, and shared, and now you're going to have with shared UI. And inside shared UI, you're going to have, once again, dependent code that depends on the platform. So Compose for Android uses the Android X Compose. Compose for desktop uses the JetBrains Compose. So basically, we're going to edit that shared UI Gradle file to add the JetBrains Compose. And of course, now that we're loading this plugin, we're also going to say which libraries we're going to use. So we're going to use Foundation, Runtime, Foundation again, Material Icons Extended, UI, and UI Tooling. And now, if we try to compile the Android application, we're going to see this. Yes. This means that we've got duplicated classes on our code. This happens because we're using two different versions of Compose. One from Android X Compose and the other from JetBrains Compose. The solution is quite simple, okay? You just need to replace the Google one with JetBrains Compose. Internally, what this plugin is going to do is just replace if there is an Android X with the correct version. And now, if you compile your project, you're able to have Compose on Android and desktop. Once again, the big question here is, do I need to refactor the entire project? Once again, I've got good news for you. No, you don't. So Compose, it's interoperable with XML, and you can have your Compose functions and your XML code. However, if you want to share with desktop, you need to have this part with Compose. You cannot share XML code. So what challenge will you find? And of course, there's always challenges when we're talking about something new, something that's still on alpha. Once again, for me, the worst challenge was to have the setup ready. The first time I was able to compile the project, it took me 12 minutes to compile. This happened because I was just merging configurations, and I had a lot of libraries a lot of repositories that I've added on the Gradle file that was from a couple of samples. And basically, internally, what was happening, it was in loop checking each one of the repositories to see where the JetBrains Composer was. So as soon as I removed it from the project, my project compiled in 1 minute, something like that. So the initial setup is challenging. I've got a surprise for you at the end, don't worry. But trust me, this can take you several days. Also, libraries depend on the Compose version. If you used Compose on Android, you already noticed this because you want to update Kotlin version, but you couldn't because you were using Compose and they need to be compiled with the same Kotlin compiler. So you need to use a compatible one. Not all features are available for desktop and the web. There is no direct support from localization, from fonts or other resources. You need to do this by hand. And if you're familiar with live data view models, well, you don't have them, at least officially. What you have is a couple of libraries that gives you this for free. And web, it's in its initial stages. I know that it is alpha, so I've added this as red, but it's alpha, so it's on the beginning. I felt that desktop was way further than web is, but you can use it on the web with a bit of tricks, but it's doable. How to solve these issues? So for Compose, I always used Accompanist. It's a library that gives me for free a lot of features. For instance, I can manipulate the keyboard, the IB controller. I can have swap to refresh by just calling a function, pager, permissions. A lot of things are given for me for free. And I was hoping to have them on desktop until I saw this issue. It's something that Chris Bain is currently working on. And basically it says, okay, Compose works for Android, but desktop and web, at least for now, not. So fortunately, we have an amazing community, so community to the rescue. And there is a new version of Accompanist by CR10 that ported some of these libraries. Happily, it ported the ones that I was needing. So you've got these libraries that work for desktop. Unfortunately, here, they only work on desktop. So yeah, this was my immediately response. So I decided to see how we ported these features for desktop, and I noticed that basically it's just using the JVM version. So this is the Gradle file. It's not exporting anything to Android. So there is a quick solution here. I basically added the Android library plugin. I added the Android target, and then defined the source sets. And of course, since I'm now compiling for Android, I needed to say which is the version of compile SDK, the default configuration, the compile options. And once everything was done, I now have a company that supports Android and desktop. Talking about image loading, we used to have, or we have Glide, we have Picasso, and a couple of years ago we started to have Coil. And the great advantage of Coil is that it's already available for Compose. Unfortunately, it's not available for Compose for desktop, okay? And according to Colin, that's the main developer, let's say, he thinks that probably it would be never available because there is a lot of classes that he's using that belong to the Android framework. Once again, community for the rescue, and we've got Camel. Camel is a library built by the community that allows to load images for Android and desktop. It uses Ktor in the background and it works really, really well. So basically, if you add this with Coil and we want to just migrate to Camel, you used to have a request and then you use that request as a pointer that you add to an image. Now you just need to use a Camel image and basically you can have the same pointer resource. So basically I can reuse almost all the code and it's even with less lines, so great. Worth to mention that the last version of Camel supports the Compose version from JetBrains 1.0.0 Alpha 3. So there's no support for Alpha 4 now. I've opened that issue. Hopefully that he is going to solve it in the near future, but for now you can use it without any problem with Alpha 3. If we're talking about resources, let's imagine that we want to load an image. Well, there is no direct support because typically when you want to load an image on Android, you're going to access the R file that contains all the resources and then on the drawable. And well, you want to share the resource and desktop doesn't have an R file. So once again, let's call KMP to the rescue and we need to use it to add this support for Android and desktop. So we first start by creating two functions. In this case, I'm going to expect someone that's going to define the icon about, and someone is going to define the icon home that's going to be used on the bottom bar. So on the Android side, I'm going to use RW. So I'm going to say that on Android, I'm going to use the RW class file. And in desktop, I'm just going to give the path and access to that image. Now imagine that we want to access a custom font. this also doesn't exist for free when we want to share with Compose. So typically we would do something like this. We have a style and then we import that style, and on that style we define the font, and we once again use the resource file to access that reference. Now what we need to do, and we can share this font file, is that we need once again to implement an expect class where someone is going to define the name and the resource where it is, and it will output a font. So once again, we go to Android main, and in this case, we're going to use everything that Android gives us. So we're going to use the context, we're going to use the resources methods and get identifier for the font that we're going to use. On desktop, it's way easier because we can directly access to font, because we can just send a path and we have access to it. If you want to use the lifecycle, the view model, the live data navigation that we're already familiar with Android, you can use this pre-compose library by Taster. And basically you just need to change the activity that you are extending. You need to extend this activity, and you have all of this for free. Okay, you just need to change the imports and you can reuse most of the code. So what about web? So web, it's on its initial stage, and the paradigm is quite different. So it's more focused on DOM rendering than having all of these components as we had with Compose, like the modifiers, the file max width, all of this. We only have a set of components that we can use, for instance, box, bottom, column, and for the rest of them, we need to use these functions. So I wanted to just have a column with max width, and of course I needed to use the width, but then I needed to add the same 100% in order to have it full width. Of course, we can always encapsulate this under composable functions, but this is going to take a lot of time to do them. I believe on the near future, we're going to be able to do this directly and also share this code. For now, it will take you some time. So talking about web, sharing logic, the business logic works almost perfectly. You need to take into account that the generated GS file might be a bit too big, but once again, you can use gzip, you can use minify to compress it and to be smaller. Sharing the UI, it's going to take you some time to create all of these components, and most of the libraries don't have support for GS, at least for now. In any case, it's good to know that the team is working fast on this, and in the upcoming months, we're going to see, I bet, new developments. So it's always good to have a pet project that we can test and see how things are evolving. So getting everything together. So Kotlin Multiplatform Mobile, for me, it's a green light. You can use it in production. I'm already using it. Once again, Compose also. For me, it has a green light. Compose Desktop is something that you should dive in if you want to have a desktop application. Compose for a web, if you don't have anything more to do, you can do it, but I would just have it as a pet project and not something production ready. Documentation and samples, well, it's still on alpha, so we have a bit of documentation, but it's not as much as I was hoping. In any case, the Kotlin Lang Slack, it's great to ask questions there. You've got people from Google, from JetBrains answering, a lot of communities trying to push it forward. So the community and support, it's more than green light here. A couple of resources here. All the Compose samples available on Google GitHubs, on JetBrains, on Fuzzo Playground. The Jetpack Compose internals book is free during this month, thanks to Snap Automobile. And you've got the Kotlin Slack. But, and I'm going to have here my Steve Jobs moment. There is one more thing. Before I forget, if you have any questions for me, you can add them on the chat. So I'm going to answer everything at the end. We've talked about difficulty, and I've shown you the full challenge here that you have to create everything. But we can reduce this experience a bit and make things a bit lighter. So I've created a template that's called Alicerce. This in Portuguese means foundation. That already is going to give you a template that you can use for multi-platform, both on business logic and multi-platform in Compose. I'm going to tweet the link in a couple of days. I'm still finishing a couple of things because I want this to be really generic, and anyone can just go grab this link, define a name, a package name, and automatically will have its starter project. I don't want people to lose time on having everything configured like I did. So feel free to use it. I'm of course open to feedback, to contributions. If you have any question, don't hesitate to ask me. Once again, you can find me on Twitter at Mota, and I hope you have a lot of questions for me to answer. Let's see what I can help. Hello everyone, once again, now in full screen mode. Glad you like the t-shirt. So this t-shirt is amazing from MobiConf, okay. Thank God I'm unmuted, and I noticed that I was unmuted, otherwise this would be really fun for you to see, to try to discover what I'm saying just looking at my lips. So what IDE do you use to compile and run all those app versions? Do we need both? So I've done everything using Android Studio. I just installed the KMM plugin and I'm able to run it without any problem. So without any problem between codes, because I ended up doing some invalidation restart, but typically after I do that, I can code without any problem. And I do them because there is an issue that sometimes I lose autocomplete, and it's really, really handy. It's also important to mention that I'm currently using Arctic Fox, but I'm using Arctic Fox and not Bumblebee, if I'm not mistaken, it's the last one, because my Mac is an M1 and there is some issues with the M1 with the Bumblebee version. So why iOS developer is not in the bar? Of course, iOS developer is in the bar. Of course, I love iOS developers. The thing here is that for now you can only share the business logic with iOS. For now, there is no support for Compose. Perhaps on the nearby future next year there might be something. Once again, you have the compiler and the runtime, so you basically just need to add the iOS UI toolkit for Compose. But for now, the focus is to have desktop and web ready. So answer to the question, are there any plans to develop Compose library for iOS UI? I would say perhaps people already thought about that, but they're focused on having these two first stable, and who knows, perhaps next year. There's going to be a Kotlin event starting in the end of this month, and it's going until November, and they're going to make a lot of releases. Perhaps they're going to speak something about it. That part I don't know. So I'm still open for more questions. I think you have 2 more minutes for questions. What can I say? I hope everyone is enthusiastic about Kotlin Multiplatform and with Compose Multiplatform. Don't worry if it feels that it's a bit overwhelming at first. We're working with 2 technologies that we're adding more and more platforms to it. So it's usual that you're going to, we have an expression in Portuguese that it means that we're breaking stone. It means that you will need to discover some things that aren't available. For instance, the resources, you don't have the resource given for you, so I needed to implement it myself. But once again, the Kotlin Lang Slack, it's an amazing place to ask questions. So if you have any doubt, if you have any problem, just ask there or reach me directly. I'm happy to answer any question. I'm going to tweet the slides afterward along with all the links, so feel free also to reach me on Twitter that you can see all the materials that I've built. So if I have any question, feel free to reach me afterwards. I think we're running out of time. It was a pleasure to have you all on the other side, and hopefully we'll see you again next year.